Thank you everyone for being here. This is the first, my name is Marco Turchi and I'm the secretary of the SIG on Spoken Language Translation. And this is the first SLT seminar, and welcome to be here today. So before starting, today we have an interesting presentation by Professor Katsuhito Sudoh on simultaneous speech-to-speech translation. But before starting, I would like to leave the floor to Professor Nakamura, who is the president of the SIG. So Satoshi, just let me share my screen and then I will present the slide, okay?
Yeah, please allow me to share the screen.
I think you should be good now.
Okay, thank you very much. Okay, so thank you very much for coming and joining this SLT talk. And I'm Satoshi Nakamura from NAIST, Japan, and also the chair of the ISCA SIG SLT, Spoken Language Translation. So ISCA SIG on Spoken Language Translation was established in 2020, and we proposed the SIG newly, and the SIG ISCA allowed us to establish this special interest group. So topics of this SLT, SIG SLT, is simultaneous translation and the interpretation, okay, the speech dubbing and the speech-to-text translation and the speech-to-speech translation, cross-lingual communication, including paralinguistic, emotional, and or multimodal information and related areas. And the purpose of this SIG is provide members of ISCA with a special interest in spoken language translation and its related areas. And the B, organize challenges and evaluation campaigns. Actually, this is related to the IWSLT shared task. And sponsor and organize an international conference on spoken language translation, IWSLT, and meeting, satellite, and the tutorials. And so this is, we have to follow the framework of ISCA SIG bylaws. And also, we're going to make available open source code and the data resource, best practice and tools and evaluation metrics relevant to spoken language translation. So chair is me for now, and secretary is Marco. And so we rotate, probably we are going to rotate this chair and the secretary. And the main activities of this SIG is the IWSLT actually. So IWSLT started in 2014. And actually this is, how many years ago? 18 years ago, 19 years ago. And so Alex Weber is here, and me and so other sister members initiated this IWSLT. And IWSLT is a premier annual scientific conference dedicated to all aspects of spoken language translation. For 18 years running, the conference has published and organized key evaluation campaign in the field, including creation of requisite data suite and the benchmarks and the metrics and key tasks and define progress in the field. So this is actually, this is the IWSLT is the history of speech translation. And the specific papers and the system descriptions documenting the state-of-the-art archived by participating teams and contributing key algorithmic advances are presented at the conference. From 2021, there was conference was actually on August. So IWSLT became ACL workshop, and we have a scientific and technology papers and 4 shared tasks with 22 participants at the time. And in 2022, so IWSLT 2022 is scheduled in May, and as a ACL workshop as well. And here we have 1, 2, 3, 4, 5, 6, 7, 8 shared tasks. So number of shared tasks is increasing, and the number of participants hopefully it will increase as well. So please join this shared task and the scientific technology paper submission. So here, this is the new activities of the SIG-SLT. Actually, Marco proposed this talk series, and this is very new. And we're gonna invite speakers in this community. And so actually, some people present their activities in ACL and sometimes in InterSpeech and ICAS, the various conferences and IWSLT as well. But here we ask all the colleagues to present in this talk series. And after talk series, we have a more, how to say, the casual discussion time. And then we will push the speech translation research activities. Okay, so to achieve this goal in agreement with IWSLT Steering Committee, actually Alex Weibel is the chair of this IWSLT Steering Committee. The SIG is planning to organize a series of virtual seminars on different aspects of speech translation. So this is very good. And for this reason, we are looking for your help, meaning that we expect all the participants today will be a next speaker of this SIG-SLT talk series. To express your interest, please let us know by email, and we are happy to your proposal. Okay, so this is the introduction to this SIG talk series, and the talk will be recorded and uploaded to the IWSLT website. Thank you very much for your attention.
Thank you, Satoshi, for the introduction of the SIG and the seminars. And let's go ahead. So thanks a lot again, Satoshi. So now I would like to leave the floor to Katsuhito Sudoh, who is professor at NAIST Institute. And today he will talk about one of his recent work on simultaneous speech-to-speech translation. So just to complement what Professor Nakamura says, so this seminar is like very informal. We are among friends, and I think it's a good way for a young researcher to, not only young, but to present their work and to create connection. In particular, in this period of virtual conference, to show your face behind the name that you can see on the paper, it's an interesting opportunity. So we hope that this is the beginning of a long series of seminars. So Katsuhito, thanks a lot for being our first speaker, and the floor is yours. And we hope there will be a lot of questions at the end of your seminar. Thanks a lot.
Okay, thank you very much for the introduction. It's my great honor to have an opportunity to give a talk here at the first SLT seminar. So the title of my talk is the Simultaneous Speech Translation with Transformer-Based Incremental ASR MT and TTS. This is a joint work with our members headed by Satoshi Nakamura. So, and there's many our students. Okay, go ahead. So this is supported by the Japanese government project, our research, large research project about the simultaneous translation. Okay. So this talk is originally based on our presentation at the last year's conference named ODA and Coposta. So this is a joint work with our students, and that's this is the proceedings also available at the IEEE Explorer, and this paper won the best student paper award at that conference. Okay. So I'd like to show you a quick video for our system. I hope you can hear the audio. So, yeah, okay. This is a very short video from the TED Talks that are applying our sort of system to generate the subtitles and the TTS speech after the Japanese translation. So the background of this work is about our research activities on simultaneous speech-to-speech translation from English to Japanese. So the task is the simultaneous translation. So we are not waiting for the end of the sentence. So this should be very important for real-time communications in lectures or this kind of speech, the public speech. So this task is a speech-to-speech translation. So we don't have any displays for closed captions, and the speech-based communication would be very natural for our human beings. And this also the simultaneous translation. So no interpretation effort like summarization. Usually we use the term the simultaneous interpretation for this kind of activities, but our current status is not so sophisticated as the simultaneous interpretation. This is just a kind of the machine translation work. So we call it as simultaneous translation. So the task is also the English to Japanese translation. It's a very syntactical distant language pair. So it's really difficult problem for machine translation. So especially in the age of statistical machine translation, but we usually use the neural machine translation this time. But we still have a very important problem in English to Japanese translation in simultaneous condition. So as I said, so the typical challenge in English to Japanese simultaneous machine translation is the long distance reordering required for the translation from English to Japanese. So this is an example taken from a book, taken from a paper written by the Professor Mizuno in Japan. So the source sentence consisted of these 9 phrases. So in the end of this sentence, we can see the long relative clause here. So in Japanese translation, this relative clause should be translated in the beginning of the sentence. So this one is this is a example translation of the sentence. So as you can see, the order of the phrases are completely opposite from the original English sentence. So except for the subject with number 1. So in English sentence, the phrase to say is translated in the last phrase in the Japanese side. So they must. So this kind of phenomena, happens so frequently in English to Japanese translation, and we have serious difficulty to translating the English Japanese case, especially in the simultaneous condition. So the simultaneous interpreters tries to translate it very quickly, simultaneously, using some kind of techniques. So using the called monotonic translation. So they reordered the Japanese sentence, so according to the original English word order, and they split the sentence immediately before the relative clause in the English side. So they this one is also taken from the Mizuno's paper. And the first we translate. First, interpreter translate the sentence from phrase 1 to phrase 6, and in this way. And in addition, they add the relative clause, translation of the relative clause at the tail of the sentence in this way. So in this kind of reordering in the Japanese side, so an interpreter can interpret the English input the same order, almost the same order as in the English input. So this is a kind of very specific or sophisticated technique to translate the English sentence to Japanese in the simultaneous condition. So considering this kind of phenomena, we started the simultaneous translation research. So handling this kind of difficulties, but we started this kind of activity using the baseline technology called weight K, proposed by Minbo in ASR 29 2019. So it's very simple, but actually it's not really appropriate for this long distance reloading problem in English Japanese, but we tried first we tried it to implement our system. So we tried a relatively larger number of K, the 10, 20, and 30 for experiments later. And the second part of this talk, So I'd like to introduce our recent activities called incremental constituent label prediction. It's presented in the last year's WMT. So we decided when to start segment translation according to the constituent level comingness. So this is motivated by our lab's previous study, so presented in the ASR 2015 in the age of statistical machine translation. Okay. So this is the overview of our simultaneous speech translation system. It consists of a cascade of 3 modules. So incremental ASR and incremental MT and the incremental TTS. So we started from English speech as an input, and we obtained intermediate English transcripts using incremental ASR, and we obtained intermediate Japanese MT results using the incremental MT, and finally we got outputs Japanese speech segments using the incremental TTS. So the incremental speech recognition part is implemented by our previous research presented in Interspeech 2019. So this is transformer-based extension of our ASR-based knowledge distribution. This ASR, incremental speech recognition, mimics the offline version of, and the offline, mimics the attention. And attention in the offline ASR. Then we extended in the transformer-based ASR to implement the transformer-based and automatic speech recognition. So the machine translation part, we still use the weight, the technology is called weight K, using the DA of the decoding process just in the K input tokens. This is really simple. So, this one is a very simple example from the Japanese translation is weight 3. We just weight the 3 input tokens and started translation to the output decoding output from the 4th step in the translation process. So we also apply the sequence level knowledge distillation for the translation from in Japanese in the relatively low resource conditions using the TED Talks data with hundreds of thousands of sentences, and the very limited condition of spoken language translation. We use this kind of sequence level knowledge distribution to improve the translation performance in spoken language translation. So we also applied another technology called Japanese chunk shuffling to reveal to apply some kind of free word order in Japanese language, but it doesn't work well. So actually, it doesn't work well in our experiment. The third module is the incremental text-speech synthesis. This is also based on the transformer TTS, and we extend it to the incremental implementation. So it takes that fixed number of Japanese words and converted them into kana. The kana is a Japanese phonograms required to generate Japanese speech. So it predicts a mail spectrogram and generates the speech signals with CPHG and the Griffin limb, and the process continues until the end of the segment to the step by step. Okay, so we evaluated this cascade system. So by this procedure, the cascade system was is evaluated using TED Talks data, like the simultaneous translation task in IWSAT. We apply this kind of evaluation metrics. The first is we use the ear voice span to evaluate system level latency. So this is a span between the start of the input speech and the output speech. We also measured module level qualities using the word relay rate for automatic speech recognition, and the blue for the speech-to-text translation, and L2 norm and AB preference test to evaluate the TTS. So we will compare three latency regimes as using the IWSAT with different hyperparameter settings for latencies, the low and the medium and high latency conditions to compare the differences, to compare differences, the latency and accuracy. Okay, so this is a latency result of three different latency regimes. So in the low latency conditions, the total delay, so evaluate calculated as a ear voice span, was about 9 seconds. It's really large delay, as in the as shown in the as shown in the video in the beginning of this talk. And in the medium condition, it grows in the 12 seconds and 17 seconds with a high latency region. It's a really large delay in the simultaneous translation, but but we require this kind of very large latency to translate into Japanese accurately. We guess. Okay, we use these 5 parameters to for these latency regimes. Okay, this is a quality evaluation result in the automatic speech recognition. So we achieved the 25 word rate in the incremental conditions. So opposed to the about the 21% of word rate in non-incremental offline condition. I think it's quite good result here. And the for the evaluation of speech-to-text translation, we got very low Blue score with a 9.4. And we also conducted subjective evaluation for this translation result in adequacy and fluency. We got the 3.3 adequacy and the 3.8 fluency by the incremental MT. And it's often the offline version, so the Blue was a little bit high, that to 12.8, but subjective evaluation results is not so far from the incremental version, and it's not really good, but the reasonable performance, I think. Okay, this is a quality evaluation. This is a result of the quality evaluation for the text speech, and we got almost comparable result with the offline version. So L2 norm for the offline transformer is 0.51, and the incremental version achieved 0.57 L2 norm loss. And the result in preference test, oops, so slide timing is recording. So you might practice practice. Sorry, the AV preference test result shows our transformer-based ITTS as also competitively work with in a different latency. If you choose to wait for 7 words for the TTS, we got a little bit higher preference in the preference test, but it's not so large. There's not so large difference between the 5 words and 7 words latency in the ITTS. Okay, so this shows the delays by our Cascade system. So we started. This is the start of the talk, and in low latency condition, the ASR delay with about 1 second, the IMT delay with 4 seconds, and ITTS delay with about 3 seconds. And this is a ear voice span about 8 seconds here. And this is the first TTS output in the first phrase in Japanese, and this is the output for the second phrase. And we can see the second TTS segment is not available yet, and at the time of the end of the first segment output. But in second, the medium and high latency conditions, the output speech is connected. So even if we have so many numbers of output speech segments, so this shows so we found a problem here. So we call it the cumulative speaking delay. So we have so many numbers of segment speech output by TTS, but so here the first segment, first speech segment is finished before the second segment becomes available. But the third and the fourth and fifth and the sixth segments were available. So before the speech output to the previous speech TTS segment. So later TTS segments have to wait at the end of the play of the previous segments. So it causes a very long delay in the speech outputs for very long inputs. So in the actual simultaneous translation experiment, we have the 10-minute TED talks, but the actual speech output should be longer than we expected, and it takes 1 minute or 2 minutes after the end of the original talk. This is a really important problem in this kind of application, I think. So this is so far I talked about our previous work presented in the last year's conference. So this is our recent activities presented and presented in the WMT last year. It's called the incremental constituent level prediction. So this is used to determine the timing of the segmental translation in the English to Japanese simultaneous translation. So we start translating the segmental input so far, and according to label prediction for the next constituent. And we also use the one loop ahead to predict the constituent label. So suppose we have an input I here, but we like to use the one loop ahead. So we wait for the next input words, So if we suppose we observe the both at our input, second input word, we predict the constituent label for starting from this word, broad, so that we can easily guess. This is the part of the verb phrase. And in English Japanese translation, the verb phrase is a very important signal for starting translation of the preceding noun phrase. So we start the translation of the phrase, the input segment I, and then we got the translation from Japanese translation watashi wa. And go on to the next step. So we observe the input word a. Now this is we can guess that this is the beginning of the noun phrase. And go on to the next step. We got the next input word pen. This should be in a noun. Finally, we got the end of sentence signal and translate the remaining part of the sentence. So using the, actually we translate the whole sentence, I bought a pen, but we already have this prefix translation. So we use this prefix as a decoding prefix, apply the force decoding for these two words in the decoding process. And we got the translation of the input sentence, watashi wa pen o katta, using the prefix determined so far. Okay, so actually also we have to define the segmentation rules to when we start segmental translation, when we observe what kind of constituent labels. So for our first rule, we segment the input coming just before the constituent label S and TP. This is a very reasonable rule used in English to Japanese translation. And we also applied some the exceptional rules to avoid frequent segmentation. If the previous labels S of BP do not segment the input, so we don't segment the inputs. We don't segment the inputs repeatedly, and we will actually we have some problems with the two rules before. If the chunk is shorter than the minimum length, we do not segment the input to keep the kind of segment length in the translation process. If we have very short segment in translation, it should not give the good translation result. So we keep some length of the input segment for this kind of translation. So this is a result on the English-Japanese translation for the IWSAT dev set for 2021. We got some improvements by our proposed method over the baseline, the weight gain, a meaningful unit, and the fixed segmentation using a predefined length. So for on the average lagging blue curves. So this is in mid-scale average lagging conditions. So our proposed method achieved higher blue scores than the other baselines. However, it doesn't work well in English German conditions. So because of the segmentation rule, optimized to English to Japanese condition. In English German translation, we can segment the inputs more frequently than the English Japanese conditions with using the different segmentation rules. So it doesn't work. So we also tried this ICLP, the proposed method, into our speech-to-speech translation system, and we also evaluated the speech-to-text conditions by subjective evaluation in the adequacy fluency. So we tried this one and compared with the baselines using weight K. We got a slight improvement over the different latency regimes. And the results, and adequacy and fluency results, it's quite good, I think. So this is a top line ASR. This is a system using the ASR results, but the offline translation. And the rightmost one is using the gold standard transcription with offline translation. So the difference is not so large, I think. Okay. So this is the conclusion of this talk. So our English to Japanese simultaneous speech-to-speech translation system, using transformer-based incremental modules, so automatic incremental ASR, and incremental MT, and incremental TTS. The module level delays are problematic, still very problematic, especially in the cumulative TTS delay. And the second, the ICLP-based simultaneous MT in the second part, not perform the weight K in English-Japanese conditions, but not the same as not the same in English-German translation. So actually, syntactic information helps in simultaneous condition. Our future work includes aggressive anticipation to reduce the delay, so especially in the TTS, and is controlling speaking inclination from TTS, and reasonable evaluation for this kind of task. We just use the average lagging and blue or some kind of other kind of automatic evaluation metrics for machine translation, and we don't have we don't have a good evaluation scheme in this kind of task, the simultaneous interpretation. So considering a comprehension or the information delivery or something like that, we should explore the way to evaluate the simultaneous translation, speech-to-speech simultaneous translation. So we related to our organization of IWSAT share task, we distributed we are distributing the simultaneous interpretation corpus as we presented in the last year's IWCT. So this is the link of our corpus. Please visit our website to use to get the corpus. Okay, that's the end of my talk. Thank you very much.
Thanks a lot, Katsuhito, for the very interesting talk. So thanks a
Thank you very
lot. So now it's time for questions. So who is the brave who start with the first question? I have plenty, but I want to leave the floor to others. So please unmute yourself and ask question to Katsuhito if you have it.
Marco, I'm not brave, but I'm tired. I'm about to go to bed.
Okay, Alex. Well, we know that you are also brave, so please go ahead.
So let me ask the first question. Katsuhito, so this is very interesting and of course very intriguing, as several groups are now also playing with this question of adding TTS and synthesis. Now, human interpreters, as you know, if they are wrong in their translation, if they were too aggressive in outputting input that later turned out to be wrong, in text, we avoid that problem by just simply revising the output text. But in speech, that's of course hard. Once you have spoken it, it's out, and then you cannot take it back. And what human interpreters do is they have very complex strategies to then correct what they just said. I'm sure you must have thought about this whole question as soon as you touch TTS, and I'd like to hear your thoughts on that.
Yeah, that's a very good question. So, actually, even in simultaneous interpretation, the interpreters use some kind of corrections in their interpretation. So when they spoke the wrong translation, wrong interpretation kind of way. So actually, in automatic simultaneous translation, simultaneous interpretation can do that, but it's really difficult problem to repair the previously generated wrong translation or interpretation. And this is a really interesting problem, I think. But actually, currently we are trying to generate the perfect translation at first, but I think it's really a problem in the aggressive anticipation in this kind of process. Also, we have to explore that kind of way to do the same thing as the human interpreters, as you said.
Thanks a lot. Alex, do you have any other question? Otherwise, there is Sebastian.
I'm fine.
Sebastian, go ahead.
One question, if I've seen that correctly, there don't seem to be any punctuation in the transcription. Is that correct? And can you maybe elaborate a little bit upon the decision on whether or not to include punctuation, and maybe what implication punctuation could have actually on the TTS?
So actually, we completely ignore the punctuations in the system. But yeah, as you said, the punctuation is really informative for ASR and MT and also TTS. Yeah, maybe we could include that kind of information, but actually the prediction of that kind of punctuations are really difficult for us. We ignore. Currently, we ignore. Well, we should try. Yeah, that's a very important suggestion for us.
Do you have any experience or any insight on whether automatic punctuation might be helpful for the user, or whether current punctuation prediction is still too bad, so that it actually would distract the user? Is there sort of, do we know anything on that balance?
Yeah, punctuation prediction is a really important problem. I tried the punctuation prediction for the IWCL task in more than 10 years ago. I found that it's very important for actual translation process. But actually, as you said, the punctuation is really important for users, I think, as you said. but okay, so it's really important. And I think the punctuation information given in the automatic transcription in Zoom system, I think is really helpful to me. And it should be included in also in the translation to improve the comprehension for the users.
My question is more along the lines, do we know that it is helpful? I'm not aware of any study actually that really focuses the punctuation yet.
So I don't know the related work in punctuations in this kind of conditions, but I believe it's really important.
Thank you very much.
Yeah, thank you.
Lee, go ahead.
Yeah, thank you, Katsuhito. I have one question related to the incremental, when you try to build the segmentation rule to determine when to start translating. Yes.
Yeah.
And then, I mean, when we look into the rules, we can see that it's not really tailored to the Japanese, but also very sensible for me for other languages as well. For example, like from English to German, we can also see that maybe the segmentation rule here are working, but why, I mean, is not working as you reported in the English to German?
So I guess that, yeah, okay, go ahead.
No, I just
yeah, I guess.
just wonder, like, I mean, like, it's very sensible for me. The rules is not really, you know, Japanese independent dependent rules, but yeah, but why it's not working for the English to German?
So I guess the current rule is not sufficient for the segmentation in English German condition, because the English German is the syntactically different, but it's not it's not very so different than the English Japanese case. So actually we can include more segmentation, so more segmentation rules for the English German case to improve their to decrease the latency. So this is a very pessimistic. These rules are very pessimistic in English German condition, and I think it's the reason for the degradation in the English German case.
Have you looked into the output of the English to German in this case? I know that maybe you don't know German.
Yeah. Yes.
I don't know
Sorry,
that either, but I think there are maybe some students because, like, for me, the second and the third rule here are very sensible also for other maybe many languages as well, not only, you know, Japanese.
Yeah. Currently, we don't have German students, so we couldn't evaluate the output, and the propose a new rules for English German. But as you said, we could do that with the German speaking people. Yeah, this kind of language, some of the language dependent rules widely used in the age of statistical machine translation more than 10 years ago, as I worked in the English Japanese and Chinese Japanese translation. I propose this kind of rules to do that. That actually it should be it should be considered the language. We have to define the different rules for different languages. It's really complicated, and we should develop some technology to explore to find the rules or find a more sophisticated way to buy some kind of statistical models to find the rules or find a segmentation model. In near future, if we are going on to this line of work.
Thanks.
Yeah, thank you.
Any other question? Okay, I have a couple ones. So the first one is, sorry, when I look at the delay, I noticed that the TTS had a very huge delay, if I understood correctly. What is the reason of this delay? I mean, is the fact that it's computational intensive, or there is some kind of weight cave strategy as well?
Yeah, so I'm not really sure about the reason of the delays, but we take about 4 seconds of 5 seconds delay in the TTS part is almost comparable with the MT delays. So in Japanese TTS, we need some characters, Japanese characters, kana phonograms, to generate the speech. So we have to wait several words, a couple of phrases for the Japanese TTS. So it should take some time to generate the TTS segment. This is my guess.
Yeah, makes sense to me. But because I was wondering, the TTS just takes some text and produce the spectrogram. So I was okay. You answered my question. And the other question that I have is more. So now you use a cascade approach. Can you elaborate me more about the possibility of using a direct model, which can be speech to speech or speech to text, and then TTS? Do you have any thoughts about that, ideas or something?
Yes. So as you said, the end-to-end approach would be very promising for our future. And we are considering to include the speech-to-text translation, followed by the TTS, or first, and go on to the free end-to-end simultaneous translation. But actually, we should start from the speech-to-text translation, because we can include some linguistic information in the translation and the TTS. So if we use the end-to-end speech-to-speech translation, we are very limited information, linguistic information can be included, can be injected in the process, I think. So we should start we should start from the easier cascade with the speech to text translation. Yeah, this is really important. As a suggestion. Thank you very much.
Yeah, I think there is also a problem of data, because as more you go for more direct or end-to-end, more data you need in different format. They're not easy to collect, probably.
Yes, data scarcity is the largest problem. So so we just currently we have very limited number of parallel corpus with the speech. So actually, I could advertise our massive version to English Japanese. I forgot to include.
Yeah,
this is very important. So for English Japanese translation work, we use our in-house version of the English Japanese corpus in this work, but we are Marco distributing the English Japanese massive version too for this year's evaluation campaign, recent evaluation campaign. Please use their corpus.
Yeah, well, we built thanks to your contribution. So
yes, so this is based on my sentence alignment with the English Japanese.
Okay, so thanks for your answer, Katsuhito. Any other questions?
Yeah. So there are some questions in chat box.
I think it's a comment about the question by Sebastian on the segmentation, if I'm not wrong. Sorry, punctuation. Auto-punct, yeah.
I can't.
So I don't see, I mean, at least in my chat, I don't see any question. So I think last chance for the last question. Okay, so, okay. Dan, please.
Thank you for the presentation. I would like to ask, so you mentioned that you use word K in machine translation, and I would like to ask if the number of K in training and in test the same?
Yes, they are the same. So we tried the different conditions, but the K values in training and testing should be, was the same.
Okay.
Yeah, actually, as you said, we tried the different values in test time. So as the original paper, the test time weight K in the original paper, but we believe the K value should be the same in the training and test conditions.
So you tried, or you also tried other experiments with the different K in training and test, but
no.
No, okay.
No,
okay.
Actually, but maybe it should be it could be tried.
Okay. Thank you.
Yeah, thank you very much for the question.
Okay, so I think thanks a lot, Katsuhito, for the very interesting talk, and I think it's been the great first talk of our seminars.
Yeah, thank you very much.
You're welcome. So, well, if there are not any other questions, I would like to thank everyone for being here today, for one that are late in the night and early in the morning. So thank you, everyone. We are really looking, we believe as SLT SIG, this is very important initiative. So we really encourage students, everyone to propose themselves for a presentation. As you can see, it's very informal environment, so you don't need to be stressed too much about presenting your work, and we believe it's very useful for showing your work to other colleagues, in particular in this period where most of the conferences are virtual. So thanks everyone. Thanks a lot, Professor Nakamura, for helping me and for supporting in this initiative. And yeah, the next talk is the 6th of April. And Marco Guido from FBK, we talk about how to use direct model in simultaneous in interpreting. So thanks a lot, everyone. And everything will be registered and available on the AWSLT lecture website. Thanks a lot, everyone, for being here.
Thank you all.